All right, welcome back to our unit on matter. Today's topic is atoms, isotopes, and ions. Lesson 4 of 4. Your objectives are as follows. You will review the structure of the atom. You will learn the difference between the atomic number and mass number for an element. You will learn what an isotope is. You will learn what an ion is and how they form. And you will learn the difference between a cation and anion. Okay, so for your quick write. Okay, so what components do you think make up an atom? What is in the nucleus of an atom? And how big is the nucleus of an atom when compared to the entire atom? Okay, go ahead and pause this while you do your quick write. I'm going to move on. Okay, so atoms. All matter is made of tiny particles called atoms. An atom is the smallest particle of an element that has the properties of that element. Atoms are composed of a dense center region called a nucleus. The nucleus is made up of positive particles called protons and neutral particles called neutrons. Atoms are also made up of an outer electron cloud where negatively charged particles known as electrons can be found going around the nucleus. Okay, so the actual size of the nucleus. Okay, most models of atoms are not to scale. Okay, so let's consider, like I said, the actual size of the nucleus. So imagine an atom is the size of a baseball stadium. Okay, on this scale, the nucleus would be about the size of a pea on the pitcher's mound. The electron cloud and electrons that surround the nucleus would occupy the size of the stadium. Okay, so the nucleus is incredibly small compared to the entire size of the atom. Okay, so the electron cloud is essentially an unoccupied region of empty space. So an atom is really just, like I said, empty space. So for your notes, what is an atom? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you work on this. I'm going to move on here. All right, so an atomic mass unit, AMU. What if we could weigh or mass a proton on a scale? How much do you think it would weigh? In other words, what is its mass? The actual mass of a proton is about 1.66 times 10 to the negative 24th grams. That's an incredibly light number. Well, atoms are incredibly small. It turns out that a neutron has about the same mass. Okay, 1.66 times 10 to the negative 24th grams. Like I said, that's an incredibly small number to work with. A more convenient unit to measure the mass of a proton or neutron is the atomic mass unit, AMU. 1 AMU, 1.66 times 10 to the negative 24th grams, is defined as 1/12 the mass of a carbon-12 atom. Okay, so a carbon-12 atom has 6 protons and 6 neutrons. So 1 AMU is essentially or basically the mass of 1 proton or neutron. Okay. Electrons are so light, okay, that you can usually ignore their mass relative to the atom as a whole. Okay, in other words, we don't really count the mass of electrons when we weigh an atom. Remember, all the mass or weight in an atom is in the nucleus. A proton has about 2,000 times the mass of an electron. Okay, so for your notes, what is an atomic mass unit, or AMU? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, atomic number and mass number. Atomic number is the number of protons each element has. For example, carbon here has 6 protons in its nucleus. Okay, the number of protons determines the identity of the element. In other words, all carbon atoms have to have 6 protons in their nucleus in order for it to be a carbon atom. The periodic table is listed in order of increasing atomic number. Okay. For example, hydrogen, the lightest element, has 1 proton. Helium, The next heaviest element has 2 protons, okay? And lithium has 3 protons, and so forth. So atomic symbol, atomic number, and mass number. Recall that every element on the periodic table is represented by an atomic symbol. The atomic symbol is just a 1 or 2 letter symbol used to represent every element on the periodic table. Okay, so the atomic symbol for carbon is represented by a capital C. Okay. Every atom can also be represented by a mass number and atomic number. The atomic number is the number of protons for an atom. Okay, if you recall for carbon, it's 6. So it tells us that it has 6 protons in the nucleus. Okay, remember, it is the amount of protons that determines the identity of the element, and this number will never change for carbon. So carbon always has 6 protons, so the atomic number is 6, or 6 AMU. The mass number is equal to the number of protons plus neutrons. For example, if a carbon atom has 6 protons plus 6 neutrons, it will have a mass number equal to 12. Okay, so this mass number tells us that this carbon atom has 6 protons and 6 neutrons in its nucleus. Okay, so let's consider a helium atom here. Look at its nucleus. Okay, the atomic symbol for helium is represented by He. Okay, notice the nucleus contains 2 protons, therefore its atomic number is 2, or 2 AMU. You may have also noticed that helium nucleus here has 2 neutrons in it. Okay, remember the mass number is equal to the number of protons plus neutrons, therefore its mass number is equal to 4. Okay, so 1, 2, 3, 4. 2 protons and 2 neutrons here. Okay. So, what is the difference between the atomic symbol, atomic number, and mass number? Okay, go ahead and pause this while you write this. When you're ready to move on, okay, hit play. All right, so isotopes. Isotopes are atoms of the same element but have the same number of protons but different numbers of neutrons. So let's investigate this further here. So remember, the number of protons determines the atom or element. Okay, let's take a look at our helium atom here again. Recall that helium has 2 neutrons and 2 protons in its nucleus, giving it an atomic number of 2, okay, and a mass number of 4. Okay, so we call this isotope helium-4. But what would happen if we added another neutron to the nucleus? How does the mass number change if we add another neutron? Well, let's find out and add another neutron here. Okay. So notice the number of protons and the atomic number did not change. It still has the same amount of protons. However, because we added a neutron, the mass number here went from 4 to 5. Okay. And we call this isotope helium-5. Well, what would happen if we added yet another neutron to the nucleus? How does the mass number change if we added another neutron? Well, let's find out here. Add another neutron. Okay. Notice once again the atomic number did not change, or the number of protons. Okay. But once again, because we added another neutron, the mass number increased from 5 to 6. Okay, giving us the isotope helium-6. Okay, well, let's come back to our carbon-12 atom here, or isotope, with 6 protons and 6 neutrons. Okay. 2 more isotopes of carbon exist in nature. We have carbon-13 and carbon-14. To make carbon-13 isotope, we need to add another neutron to carbon-12, seen here. So let's add another neutron here. Okay. So we now made carbon-13 with 6 protons and 7 neutrons, giving us the isotope carbon-13. So notice the mass number changed from 12 to 13 here. To make a carbon-14 isotope, we need to add another neutron to carbon-13, seen here. So let's add another neutron. Okay. Notice how the mass number changed below from 13 to 14, and the atomic number hasn't changed at all. So for your notes, what is an isotope? Question on the left-hand side, answer goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so ions. An ion is an atom that has lost or gained one or more electrons, giving it an overall charge. For example, here we have a neutral sodium atom. A neutral sodium atom has 11 protons and 11 electrons going around the nucleus. Well, what makes it neutral? Well, protons have a +1 charge and electrons, if you recall, have a -1 charge. So the fact that it has an equal amount of protons and electrons gives it a charge of 0. Or we can just simply do the math and see that -11 + 11 is equal to 0, making it neutral. But sodium is an atom that is known for losing an electron. So if an ion is an atom that has lost or gained one or more electrons, giving it an overall charge, what do you think would happen if sodium here lost an electron? What kind of charge will the sodium have on it after it loses an electron? Well, let's find out and remove the outer electron. Okay, so we're getting rid of this electron in its outer shell here. Notice there are still 11 protons in the nucleus, but now there are 10 electrons. Because it has an additional proton, the sodium atom now has a +1 charge, forming a +1 ion. Okay, or we could do the math. -10 + 11 gives us +1. Okay, so we put these brackets around it to tell us that it has a +1 charge here. Okay, so for your notes, what is an ion? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. Okay, I'm going to move on. All right, so cations versus anions. A cation is a positive ion because it has lost one or more electrons. So for example, here we have a neutral magnesium atom. A neutral magnesium atom has 12 protons and 12 electrons, so equal amounts of protons and electrons. Okay, but what kind of ion will form if magnesium here lost 2 electrons? Let's find out and remove the outer 2 electrons. Okay, so we got rid of 2 electrons here. Because it has 2 additional protons now, the magnesium atom now has a +2 charge, forming a +2 cation. Once again, we can do the math here. Okay, -10 + 12 gives us a +2 charge. So metals such as magnesium typically lose electrons to become cations. An anion is a negative ion because it has gained one or more electrons. For example, here we have a neutral fluorine atom. Okay, a neutral fluorine atom has 9 protons and 9 electrons, so equal amounts of electrons and protons. So what kind of ion, though, will form if fluorine here picked up or gained 1 electron? Let's find out and add 1 electron here. So we're putting in an electron. Okay. So because it has 1 additional electron, the fluorine atom now has a -1 charge, forming a -1 anion. Once again, we could do the math. -10 + 9 is equal to -1. So nonmetals, such as fluorine, typically gain electrons, okay, to become anions, negatively charged ions. So when an atom becomes an anion, we change the ending and add "ide" to it. So we have a fluoride atom here now. So it becomes a fluoride ion, or with a -1 charge. So for your notes, what is the difference between a cation and an anion? Okay, go ahead and pause this while you write. I'm going to move on here. All right, so practice here. Complete the table below. Okay, go ahead and pause this while you work on this. When you're ready to check your work, hit play. All right, so let's see how you did. All right, so your answer here. Because there are 6 protons, okay, the atomic number must be 6 as well, okay? And the mass number is equal to the amount of protons plus neutrons. So here we had 6 neutrons and 6 protons. So the mass number must be 12, okay? Because the charge is 0, there must be an equal amount of protons and electrons. So in this case, because there are 6 protons, there must be 6 electrons, okay? And since we know the mass number and atomic number, we can write the symbol, carbon-12 isotope, okay? All right, so try another one here. Okay, go ahead and pause this while you work on this. When you're ready to check your work, hit play. All right, let's see how you did. So because the atomic number 1 is 1 here, okay, the amount of protons must be 1 as well, okay? And the mass number is equal to the amount of protons plus neutrons. So, okay, 1 plus 2 here gives us a mass number of 3. And therefore the mass number is 3. Okay. So because we have no electrons and 1 proton, this gives the atom a +1 charge. Okay. So that's because we have 1 proton and 0 electrons. So we get an overall charge of +1. And since we know the mass number and the atomic number, we can write the symbol. This is the isotope, okay, called tritium, or hydrogen 3. All right, so summarize, okay? You can always write your own, okay? So go ahead and pause this while you do your summary, okay? And we'll see you next time.